welcome to our first ever Geography Grade 12 tutorials. Now I'm going to try to morph these in the next few days or weeks, maybe until the end of the year. But right now, this is the beginning of the year, so remember guys, a good start has a good ending. So this is me trying to encourage you to start giving it your best right now. So don't lose that pen, follow the instructions, respect your teachers, do your work, be it a classwork, homework, assignment, always be punctual and so on. And I'm telling you, you won't regret anything by the end of the year. Because in grade 12 guys, it's not about whether you pass or you fail, but it's about the quality of your results. With that said guys, let's get started. Let's look at our first ever topic in grade 12, which is called the Mid Latitude Cyclone. So don't worry guys, this topic is not going to be difficult for you because it's somehow related to what you did in grade 11. Which topic in grade 11? The global air circulation. The global air circulation. So the global air circulation, we're looking at the global pressure belt. And the first one, Sasibega, is the one at the middle of our globe, which is called, yes, it's called the equatorial low. Then we had another one at our 30-degree latitude. There we called it a subtropical high. Then Sabanenya 40 at 60 degrees, which is called the subpolar low. Then the last one, which is called the polar high. So this is 0 degrees, 30 degrees, 60 degrees, and 90 degrees. Okay, so let's go back to our topic, the Mid Latitude Cyclone. So let me break down this word into 3 parts as it is written and explain it to you so that it's easier for you to understand. Let's first look at the mid one, the mid part. So as you could have guessed by this moment, that middle. So our cyclone, okay, at the middle of our hemisphere. The middle of our hemisphere. So what's the middle of our hemisphere? From about 30 degrees to 60 degrees. The temperate parts of the world, because the same thing even in the northern hemisphere. Right, let's move on to the latitude part. So our latitude. So the latitude part guys, explain where exactly do these cyclones form. Where do they initiate? Not found now as in the mid part, but where they form. So at which latitude? At the 60-degree latitude. This way our cyclones are going to initiate. Then after they've initiated, they're going to move in the eastward direction. Right, let's go to the last one, the cyclone part. So guys, a cyclone is also referred to as a low pressure system. And we did look at the pressure system, the low pressure system in grade 11. And let's explain the characteristics. So a cyclone is characterized by high temperatures. So if it has got high temperatures, what's going to happen to the air within it? We're going to have warm rising air. Warm rising air. Then the last characteristic I'm going to remind you of is that on the low pressure system, we're going to have inward clockwise circulating air. So inward clockwise circulating air. So air circulate in a clockwise direction. Otherwise, in the northern hemisphere, it would circulate in an anti-clockwise direction. Remember now. Good. Now let's first explain our objectives guys before we get into the real stuff. So our objective by the end of this lesson, we should be able to discuss and explain the general characteristics of our cyclones. Then after that, we're going to look at the areas of formation. Where exactly do these cyclones form and found? Then we're going to explain now the recipe now for these cyclones to form, the conditions necessary for the formation. Then lastly, on this lesson, we're going to look at the 4 stages of development: the initial stage, the mature stage, the occluded stage, plus the dissipating stage. Right, now let's get started. So we're looking at the general characteristics of a mid-latitude cyclone. So let's first look at this typical image of our cyclone, guys. So this cyclone, as you can see here, we've got clouds here. These are your clouds, and you can see this is within the ocean. That's another thing you should know, guys, that these cyclone form in the oceans. Okay, and another thing you can take from this image that it is circulating clockwise, okay, in a clockwise direction, which means that this cyclone is within the southern hemisphere. So as you can see the description here, we're saying these are spiraling low pressure systems, rotating pressure systems. Okay, right, moving on. Now we're saying they consist of a pair of a cold and a warm front. They consist of a cold and a warm front. Let me explain. Let me find my eraser first. So as we move on with our lessons, I just want you to be aware before we get there. They're going to have a cold front, then they're going to have a warm front, right? They consist of a cold and a warm front. Let me explain these terms before I share with you guys. So a cold front simply means the part that leads the cold air, the forefront part of the cold front. So if we look at this cold front here, it means all of the air behind it right here, all of the air behind this cold front now is going to be cold air. That's what I mean by the forefront part of the cold air. And the same thing applies with the warm air. It simply means this is the part that leads the warm air. So that means this is a warm front. All of the air behind this warm front now is going to be warm, right? Good. So now we're saying again, they carry a lot of moisture. Why do they carry this moisture? Because they form in the oceans. We've got moisture, we've got water in the oceans that's going to form our moisture. Right, next thing you should know, guys, that this cyclone now, they travel eastwards with the jet stream. Let me explain by looking at this global pressure system now, image of it. Now, we said this cyclone, they form at the 60-degree latitude. Now, after they formed, they're going to move in an eastward direction. They're going to move in an eastward direction, where they're going to dissipate when they reach the land of South Africa. So if this is our South Africa here, it's a terrible drawing, by the way. So when they reach the South African land, which is the Western Cape, they're going to dissipate. Right, so let's move on. And they occur in families, which means that a cyclone forms after the other. A cyclone forms after the other, which usually they form in groups of 5 within about 2 to 8 days. Fine. Now, a mid-latitude cyclone, guys, is also referred to as a temperate cyclone because it forms at the temperate parts of the world, or it refers as a extratropical cyclone because it forms in areas away from the tropics, outside the boundaries of the tropics. Extra means outside the boundaries. Right, moving on to the next slide. Now this is the image of the cyclone, and you can see here we've got the pair of cold and warm front that I was talking to you about on the previous slide. Now this means that here on the warm front, behind it we've got warm air. All of this area here consists of warm air. Then all of this area here is going to consist of cold air. Right, moving on. Now they are huge. They are huge from this side to that side. Usually it is said that they can even spend up to 2,000 kilometers. And their speed would be about 30 to 50 kilometers per hour, as you can see here. Right, we're looking at the areas of formation now. Where exactly do these mid-latitude cyclones form now? They form at a 60-degree latitude. I already told you in the previous slide, right? from about 30 to 60 degree latitude at an area called the polar front. This area here about 60 degrees is referred to as a polar front. Now a polar front by definition is referred to as a boundary where two unlike masses meet. Okay, so what are these two unlike masses? Unlike because of their temperatures. Okay, so let me go back to our image so that it will be easier for you to understand. Let me go back to this image of ours. Let me do this first. So as you can see, here at our 60 degree latitude, we've got air coming from this direction, the winds which are known as the westerlies. Then we also got winds coming in this direction which are known as the polar easterlies. Now they are unlike these masses because this one is warm because it comes from the tropics, which is closer to the sun. These winds are warm. Then these winds are cold because they are coming from the poles. So that what we mean by a polar front being a boundary where two unlike masses meet. You get that? Good. Fine. Moving on. Now, what are the conditions necessary now for the formation of this cyclone? The first one, there must be large temperature differences. There must be large temperature differences between the westerlies and the easterlies, which means now these westerlies now that are coming in this direction, they must be extremely hot, very hot, and these polar easterlies now they must be very cold as well. And there must be a disturbance in the jet stream that makes the cold air pushing to the warm air. Now let's say now we've got air coming this direction, which is coming from the tropics, right? And we've got air, let me change my color. We've got air coming this direction now, which is coming from the poles. Now this is our easterlies and these are our westerlies. Now when these two air masses now meet, guys, one of these air masses must slide beneath the other one. Which one is going to do that? The cold one will do that. These easterlies are going to do that. When they meet with the westerlies, these easterlies are going to slide beneath the westerlies because the westerlies are lightweight. They are going to rise. They are going to rise because they are lightweight. Just like if you were to take a paper and you put it in water, between the dry one and the wet one, which one is likely to be blown by the wind? The one that is dry, because it's lightweighted. It's going to rise and be blown by the wind. So the same thing here. The cold air now, the cold air is going to slide beneath the warm air, while the warm air, let me look for my pen. While the warm air is going to move on top of the warm air and is going to rise. So it's going to rise, and eventually in the atmosphere it's going to form clouds, and eventually you have your rainfalls. Right, so let's move on and explain the next one. The warm air mass then rises. This is the warm air mass, which is the westerlies. The warm air mass rises over the cold air. This one is going to rise over the cold air mass, creating a low pressure cell. So a low pressure cell is going to steepen. Now the pressure gradient between the high and the low pressure is going to steepen. Right, now we're looking at the stages. Now we're going to look at stage 1, stage 2, stage 3 up to stage 4, and we're going to explain each stage, what happens here, what happens up to stage 4. Now in stage 1 at the polar front, now the two unlike air masses are moving in opposite direction. Remember, we've got westerlies moving southward and we've got easterlies moving northward, right, at the polar front, while these westerlies are pushing this direction. This one are pushing in an opposite direction. Okay, so eventually what's going to happen, a vortex is going to form here, which is going to cause the air to rotate because of that friction. Now because of that friction, this one goes that direction, this one goes this direction, and the air is going to start rotating. Now you get that, right? I think I've explained these two points. Now the wind strengthens and clouds begin to form. The more this happens, and the more we've got air rising up, which is going to form our clouds. Okay, right, now we're looking at the next stage, which is called the mature stage. Now there we're going to have our wave is going to deepen and a stronger pressure gradient develops, which means now at the center there our pressure continues and continues to drop. Now that means our pressure gradient is going to steepen. So for example, if our pressure or differences or something like this would be our, let me say this is my 30 degree, this is my 60 degree latitude. If it was something like this pressure now at 60 degree continues to drop, and it continues to drop until our pressure differences are very big. Then the pressure gradient now, as you can see, it has steepened, which causes very strong winds to move towards the 60 degree latitude. Okay, just like if you were to put a ball here, it will roll faster here than there. So the winds are going to move even more faster because of that continuous declining of the low pressure. Right, now the polar front, guys, bends and divides into two cold front and a warm front, the two fronts. As you can see, we've got a cold front and we've got a warm front. Okay, now the cold front, as I explained before, it leads the cold air sector. Here we've got cold air. The warm front leads the warm air sector. Right, this one is pushing upwards towards the equator, this one is pushing downwards towards the poles. Now next, the low pressure intensifies at the apex of the two fronts where the stormiest weathers are. There at the center now, the low pressure continues and continues to decline. That's why we're going to experience very strong storms. Okay, let's look at our second last stage. It's called the occluded stage. Now at the occluded stage, now we've got the cold front now beginning to overtake the warm front. The cold front begins to overtake. As you can see now, it's much closer to the warm front. It has moved before. It was somewhere here. Okay, it was somewhere here, but it has moved so much forward that it is overtaking the warm front. The reason for this, let me explain, is that the cold front now, it only moves in a horizontal direction, whereas the warm front now, it moves horizontal and it also rises. It uses its energy to move horizontal and to rise as well. So that's why the warm front moves slower, because it moves forward and tries to rise, whereas this one only moves horizontal, so it manages to overtake the warm front. Right, okay, at the apex the two fronts begin to form a single rain front called an occluded front. Because of that rotation at the center now, the cold and warm front, they begin now to mix to form what we call an occluded front, a mixture of a warm and a cold front. You can see this is a cold, it's a warm, cold, warm, and so on. This is called an occluded front. Right, I've already explained this term now, that the cold air, I forgot to put cold here, sorry. Supposed to say cold air moves more quickly, displacing the warm air ahead of it, because the more it moves forward, it displaces this air which is warm. Now the cold air only moves horizontally, it does not have to use the energy to rise. I explained that part. Occlusion stage is associated with nimbostratus clouds, which are going to cause our rainfalls. Right, now let's look at our last stage, guys, which is called the dissipating stage or degeneration stage, which is characterized by all the warm air rising up now and pressure gradient weakening now, or the pressure gradient weakening. If our pressure gradient was this steep, now because all of the warm air is risen up now our pressure gradient is start to go back in balance. Our pressure gradient weakens and we've got something like this again. Okay, and all pressure differences will be reduced because you see we had this much of difference before and now it is a bit balanced now. And because now we no longer have warm air rising, the clouds that were there before have rained. That is going to result in our skies being clear and only having cold air because of that warm air that has left the scene. Now this is where our tutorial ends, guys. We're going to have part 2 of this topic now. Stay tuned.